All right. All right, so 51, it says we're going to find the formula for f inverse of x, give the domain of f inverse, including any restrictions inherited from f. So the function you're given is this, which is the cubed root of x plus 5. All right, so how do we start? We're trying to find the inverse here. Who remembers? Well, first, can we rewrite f of x as another thing? We're going to do y equals the cubed root of x plus 5. I'm not doing anything yet towards finding the inverse. I'm just rewriting it. The inverse is the reverse of the x and y coordinates. So now I'm going to do that part. So x equals the cubed root of y plus 5. And then now what do I need to do? Cube both sides. We're going to solve. I'd like to color code if I can find my markers. What? Okay. Okay, so yesterday when we talked about the process of what an inverse was, do you remember how I said it was the graphs for the reflection over the line y equals x? What an inverse does is it's undoing the other function, and so to do that what we do is we reverse the x and y, and then that gives us something or a function or a rule that will undo it. Okay? And so that's the original function. Really what I've now done is made an inverse function. The rest of it, at this point, I have done the part of reversing. But we want it to be a function, so we always then need to go back and solve for y. And sometimes, like on that one example I did on Moodle last night, if you watched, sometimes that's quite a process. So at this point, I have made the switch, but now I'm going to solve for y. So I'm going to cube both sides. Does that make sense? Okay. Then I have x cubed equals y plus 5. I'm trying to solve for y. What would I do next? Okay. Now I have something that has a function that is y alone, and then I just go back and I write it in the notation that looks like this. F inverse x then is x cubed minus 5. Okay. Now, just for the heck of it, let me get my graphing calculator out of that, if I can find it. And all my stuff. If I were to put this in my graphing calculator, these two functions, so I'm going to do the inverse right here, and the cubed root is under math. It's right there. X plus 5. And you should be able to see that they're going to look like they are, you see that? If I could even graph the line y equals x and hopefully see that they are reflections of one another over that line. Okay. Some people like to think of them as undoing one another, like, for instance, how do you undo a cubed root? You cube it. How do you undo a plus 5? You subtract 5. So that hopefully makes sense that those functions undo what's happening in the other function. Does that help a little? Okay. What else? Yeah. The domain of 49? It should be all real numbers. Nope. Did you have was the cubed root the inverse? Does that make sense? No, because if you were to look at 49's domain, x cubed was the original function, looks like this. And then the cubed root, I'm going to have a hard time. something like that. Both of them, if you think, they're not going to have restrictions, and here's why. You may take the cubed root of a negative number, because a negative number cubed is negative. Where you run into problems is with even roots, like square roots. You can't take a square root of a negative number, because when you square a negative number, it becomes positive. So as long as these are odd powers, there should not be restrictions on the domain. Where we run into issues is like fourth roots or square roots. Okay? All right, anything else?
What about 45?
No, did you try it? Did you look at the example?
Yeah, I got halfway and then
Okay. I will do it. So I'm going to go right to writing it as y. Are you okay with that? In 45, this was the function that you were given, and you were asked to find the inverse. The reason why I did that example that I did on Moodle was because I think it's pretty easy to see that to undo a cube, you take the cubed root. To undo a square, this is not easy to see. So you definitely have to go through that whole process. So I'm going to reverse the x's and y's, which means I have to swap every x for a y and vice versa. So I have to do this. So I got to put it in both spots. Okay. Now so again, at this point, I have found an inverse relationship. Now I need to make it a function by solving for y, and that becomes tricky. The first thing I'm going to do is multiply both sides by y plus 1. Did you do that, Christina?
Yes.
Good. Cancels, cancels. Now let's distribute this. What do we get on that side? xy plus x equals 2y minus 3. I'm going to tell you what the process is now. We are going to gather the y terms together on one side, even though it's got an x there. We're going to gather the y terms on one side and get everything else on the other side. So, I have two options. I can move the 2y over here or the xy over there. Doesn't matter what you do. How about I'm going to move the xy over here. Are you okay with that? And then I'm going to move the 3 to the other side. So I'm going to add 3. I'm going to subtract xy. I know that's a lot of steps there, but I think you're strong enough algebra students to know what's left here is x plus 3. Agreed? Okay. And on this side, I have 2y minus xy. Who knows what to do next? Okay, do you see how both terms have a y in it? And we're trying to get y alone? We can pull that y, we could factor it out to the front. It's like a common factor. I'm going to pull the y out to the front. What I'm doing when I factor is I'm dividing. That's factoring is division. If you would divide each of these terms by y, what would be left? 2y divided by y. What's left? 2. xy divided by y. What's left? X. Just hold on a second. If you would distribute this again, don't you get what's above there? Okay. Can you solve for y now? How can I get y alone? Divide both sides by 2 minus x. So f inverse of x is x plus 3 over 2 minus x. Again, all the way up here was when we actually reversed the x's and the y's. This, making it into a function part, was kind of a process, wasn't it? So, good? Anything else? Okay.